So welcome back on to another episode. In this one, we'll be talking about counting sort algorithm. So first, as always, we're going to take a look at the theoreticals and then we'll move on to the practicals. So let's just start with the definition, then we'll move on to the steps, advantage, disadvantage, and then do the coding. So let's start with the definition. All right, so let's just take a look at the definition. So definition says counting sort is a non-comparison based sorting algorithm. So as the definition says, it does not operate on the comparisons. It is not about swapping after doing the comparisons. That particular is useful for sorting integers and other discrete items with a limited range of possible value. Unlike comparison-based sorting algorithms like quicksort, merge sort, counting sort determines the sorted order of elements by counting the occurrence, making it highly efficient for specific scenarios. So what it basically does is just look for the specific, like something which is pretty similar. So let's just say if you have two twice in the sorting, then it will put them together, and that's how it works. So this makes it a little bit more efficient when it comes to working with some specific stuff, like if you were to talk about where the counting sort algorithm is used in the real world. It is used in character sorting, radix sorting components, even in the data analysis. The counting sort is used. Now let's just take a quick look at the steps performing a counting sort algorithm. So first you have to find the range. Then what you do is count the occurrences. Then you accumulate the counts, build the output array, and then copy back to original array. So let me just give you an overview of each of those steps. So the first step is find the range. So all you have to do is determine the range of input elements, including the minimum and maximum value. So your input elements are obviously your array, and then you have to just determine the range of where does it start and where does it end. Then what you do is count the occurrence. So all you have to do is create the count array that stores the number of occurrence of each unique elements, right? Then what you do is accumulate the counts. Modify the count array by adding the previous counts to get the cumulative count, which obviously helps you determine the final position of each elements in the sorted array. That's how it works. Then what you do, the next step is build the output array. So all you have to do is iterate over the input array from right to left, specifically right from right to left, placing each element in the current position. And then all you do is just like based on the output array will be based on the cumulative counts of decreasing elements. All right, then the last step, copy back the original array. If needed, you can copy. If not needed, you don't need to. All right, let's take a look at advantages and disadvantages. So basically, line time complexity is the advantage. No comparisons, as always, as I said earlier. Stability, simplicity, and uniform distribution, because it creates multiple different arrays which hold unique values. So these are the advantages that make it efficient and faster than other sorting algorithms that we have already studied. So let's just take a look at the disadvantages before we start coding. So the disadvantages are limited range, memory usage, non-comparison, not in place. So basically it does not do the swapping stuff. It does not have the comparison stuff. Then it uses a lot of memory because it creates multiple arrays for each unique values, and it has a limited range, right? Because you cannot have like a huge data when it comes to working with this particular algorithm, because it is kind of inefficient when it comes to using large values. All right, so let's just do the coding and see how does that work. Okay, so we are on our screen right now coding. Okay, so let's just first create the function as always we do. So name the function counting sort. And as always, our first step will be to check if we have the array, and if we have the array, then does that array have elements or something like that. So what we'll do, if not array, then return array. That's it. If we don't have any kind of array, if we don't have any values in the array, if we have an empty array, or we have like the variable which does not have anything in itself, then just return the array. That's it. But if we do have something inside of it, then what we do is just find the minimum and maximum value. So that will give us a range. That was the first step, find the range. So for finding the range, we need to know the maximum value and we need to know the minimum value. Let's just look for the maximum value and minimum value. Once we do both of them, now what we do is initialize the count of array. So how do we initialize it? So all we have to do is just say count and then multiply by min minus max plus no, I think it's plus 1 or maybe 2. I guess it's 1. Yeah, but wait a second, I think I'm mistaking. Okay, it's equals to 0. Okay, yes, the count starts from the 0th index because that's the first index, multiply by the range plus 1. That's how we initialize the count of the array. This is basically the formula of initializing it. Then all you have to do is just store the count of each element. So we can understand like how many times each elements are repeated. If the element is unique, put it inside a different array. If it is repeated multiple times, put them all together into single array, and then stuff like that. Then once we're done with that, we have to accumulate the count, right? Once we accumulate the count, we are ready to build the output array. So let's just accumulate the count real quick. So to accumulate the count, all we do is for I in range, I1 is the starting point, and then we'll go to the length of the count. Okay. Then count of I plus equals to I minus 1. Then build the output array. Okay, and length of the array. And basically what we'll do is just for num in reversed. So we'll basically reverse the entire array right here, right now. Okay, for reverse, and then we'll just output let's start the count num minus min value minus 1, I guess, and that's the way we approach it. But I guess okay, let's just do that. Okay, count num minus minimum value, and I guess it's minus equals to 1. And once we're done with that, we'll copy the sorted array into the original array. For that, we all will do just for I in range, length of the array, and array of I equals to output of I. That's it. Then we'll return the array. We're done with it. These algorithms for a beginner might seem a little bit complicated, but once you go used to it, once you implement them multiple times, once you implement them for a long enough period of time, once you practice them for a long enough period of time, once you implement them on different programs, on different applications, it becomes quite easier, it becomes quite interesting, it becomes quite really, you know, easier for you to implement them. And you don't necessarily need to memorize all of these steps. All you have to understand is when to use them and where to use them and why even to start using this particular algorithm, why to use this particular algorithm, why to use that particular algorithm. You can find all of the code on ChatGPT, but you have to understand when to use and what situation to use what kind of algorithm which will be useful even in the future, which you can develop further. Like you're building an application, why are you using this particular algorithm, and is using this algorithm will be beneficial to you in future, and is it beneficial to you right here right now, and will it be beneficial for other developer to understand this and maximize the potential of this particular application. You have to think outside the box. So we have made an fucked up. All right, it's is equal to num, and I guess okay, I think it's minus 1 after main value, I think. So let's just try this. Okay, I guess it's perfect right now. CLS and just run this. All right. Okay, so perfect. So here we are done with the counting sort algorithm. See you in the next one with the next